So today we are going to learn about helium neon laser. So in the last class we were learning about ruby laser, which is a solid state laser. But it has a drawback that it can't produce continuous beam of light even though it is highly intense. So helium neon laser is a gas laser and these gas lasers are widely used. So starting from the low power helium neon laser which we commonly use in our laboratories to the gas lasers that we use in industry. So this helium neon laser has wide application in the laser life. Here we have seen, as in the case of ruby laser, we use optical pumping to achieve population inversion. But here, as in the case of gas laser, the energy levels will be very narrow. So we can't use light sources there. So here we use electrical discharge as the source for population inversion. So now we can see the construction of helium neon laser. The figure denotes the structure of a helium neon laser. So it consists of a long glass tube which has a length of 80 cm and has a diameter of 1 cm. And the helium neon gas mixture is filled inside the glass tube in the ratio 10:1. Then we supply an electrode for passing high current to make the condition of population inversion. And we have supplied two mirrors. So the first mirror is completely reflecting and the second mirror is partially reflecting. So this forms the resonant cavity. So once the stimulated emitted radiation is started with this, it will be amplified and we will get a laser output. So this is the construction of helium neon laser. Now we can see how it works. So here once the power is switched on, the high current ionizes the gas inside the glass tube, and these ions and electrons produced as a result of electrical discharge will collide with the fast moving helium atom. So this excites the helium atom from ground state to excited state F2 and F3. So after collision, the helium atom gets excited to higher energy levels F2 and F3. And this F2 and F3 are metastable state for helium atom. So these helium atoms can stand at the excited state for some time. But it can't come back to the ground state as it has more lifetime. So it can only come back to the ground state by colliding with the nearby neon atom. And as a result of collision, the neon atoms are excited to higher energy level E4 and E6. So the helium and neon atoms have almost a similar energy. So the collision results in the excitation of neon atoms from ground state to excited level E4 and E6. So this neon atom serves as the active medium for helium neon laser. This E4 and E6 are metastable state for neon atoms. So the excited neon atoms can stay for longer time at E4 and E6. As time passes, more and more neon atom gets populated at E4 and E6 and we will achieve the condition of population inversion. So a chance photon emitted will make stimulated transition from E6 to E5 or E6 to E3 and from E4 to E3. And this stimulated transition results in the laser action, and we will get lasers of different wavelength 3.39 micrometer, which is a transition from E6 to E5 and which comes in the IR region. And also we will get a transition from E6 to E3 and it has a wavelength of 6328 angstrom, which comes near the visible region, and it has red in color. And the transition from E4 to E3 will result in a wavelength of 1.15 micrometer, which is also an IR radiation. So we are getting three laser wavelength of 3.39 micrometer, 6328 angstrom and 1.15 micrometer. So we can choose the wavelength what we needed by placing the proper mirror that can reflect only particular wavelength. So if we want this red color, we can place this mirror such that it reflects only red color. So doing that, we can select the frequency of frequency that we require. And the atoms at the E3 and E5 level will undergo spontaneous emission and will come back to the E2 state. And this E2 is also a metastable state for neon atom. But if the E2 gets more and more populated, we can get a continuous laser beam. So for that, the atoms at the E2 level comes back to the ground state by colliding with the balls of the laser. So to make the collision, to make the probability of collision high, we are making the glass chamber very long and very less in diameter. That's why the dimension is 80 centimeter, 1 centimeter. Because the tube will be very narrow. So that the chances for collision of neon atom with the glass chamber will be high. Thus the excited neon atoms collide with the glass chamber and come back to the ground state. Again this process will repeat. Thus we will get a continuous laser beam. And this laser beam produced from helium neon laser is will be continuous and will have energy ranging from 1 millivolt to 50 millivolt. So this helium neon laser we can see in many places. So once we go to a supermarket, we can see their barcode readers, right? So if you have noticed, it will be red in color. So such lasers are less power, so it won't damage the human tissue also. And that laser is made of helium neon laser. And the lasers we use in our laboratories, which is made of helium neon laser. And yeah, that's it.